Okay. Hello, everyone. Sorry for the technical difficulty. We had some issues with sound, and we wanted to make sure that the presentations today could be heard. Today is, if you're on the call for SIG Talk IT operations, you're in the right place. Our topics today will cover mainframe to UD, data analysis with OpsBridge, and Vertica into BVD. And these are our presenters today, Chip Sutton from eView, longtime Micro Focus partner in the operations space, now into the OpsBridge area, and very strong in the universal CD discovery space. And Brian Bowden from Greenlight Group, and Jay Baston with Greenlight Group will talk about some of the other solutions. So today's topic, as you can see, we try to have these SIG Talks once a month, and they're designed to be customer experience type SIG Talks. So anything that the speakers can bring to the table that shares customizations, how to make these products work from a Micro Focus perspective, is what we try to bring. We have 3 sessions today, so it'll be very quick. The event is brought to you by Vivit. My name's Rocky Pisto. I'm your SIG Talk leader for the IT operations space, bringing these things to you every month. So as you listen to the presentations today, and you think you've got some added value that you can bring to the community, we'd love to hear from you. It's 12 to 18-minute conversation or a script or a demo on how you're using Micro Focus tools to make it work better in your environment. So would love to, we do this every month, and would love to hear from you. Again, those are our speakers today. You can leave tweets or questions on our Twitter site, which is Vivit SIG Talks, and we'll try to get to those if we can. This is a live session, so it's being recorded so that you can hear it after the fact. If you can't make this session, it'll be on our website, and we will send you a note as well. Here's our new control panel for this technology, so I'm afraid you guys are all guinea pigs with this new version of this tool that we're trying to use. And I think we're trying to work out the audio as well. So one of the recommendations is to dial in versus using your computer VoIP. That's going to be your best approach to getting the sound working. And if you're using Mozilla, there's been some issues with Mozilla, Firefox. I would recommend Chrome if you can. I think they're still trying to work out some of the bugs with Mozilla on this platform. So from the screen here, you can see you can choose your language at the top. You can ask questions at the bottom right. If you're calling internationally, there are international numbers that you can dial in from, and there will be handouts, actually some scripts from our third presenter. So with that, I'm going to send it over to Chip at eView Technology.
Hello, thank you, Rocky, and go ahead and get started and try to move through some of these slides quickly since we're a little bit behind schedule. Give everyone time to get the presentations done. So, okay. So today I want to talk about integration of mainframe into UD, and specifically talk about a large financial services company that has a very large environment, as you can see on the slide, over 65,000 employees, a lot of independent contractor agents, servicing a whole lot of policies and accounts, and a lot of operations centers across North America, including over 15 IBM mainframe systems. And a lot of issues that the company had related to IT operations had to do with these disparate environments, and especially with the mainframe being able to integrate everything so that they had a single picture, a single view what was happening in the IT environment. Also, skill levels becoming a problem with the increasingly diverse environment, the amount of time to be able to analyze problems across all the different environments. So their goal was to really consolidate everything that they could into a common platform, and that common platform was based on micro-focus platforms. It was using Operations Manager, transitioning to OpsBridge OMi, and also UCMDB with Universal Discovery. Prior to doing this consolidation, the mainframe environment. I'm sorry, the slides are jumping on their own for some reason. The mainframe environment was really operated as a separate silo within the organization. So the other enterprise IT environment, the operations people, really didn't have any visibility into what was happening with the mainframe. So they had multiple data sources, really no what we call single truth of operations and configuration data. So some of the capabilities that they needed, especially in the configuration management area, was to be able to see this type of data from DB2, disk storage, CICS, which is their transaction processing, IMS, another transaction processing software, MQ series for messaging information about the mainframe infrastructure, about CPUs, network connectivity, a lot of the same kind of things that they want to see in the other environments. So with the integration of mainframe discovery into the micro-focus platform, they were able to get this, including all of the different IT environments and the IBM mainframes using this. And this is a picture, and we'll do a quick demo and look at this. In the demo, but the architecture will give you an idea of how they do this integration and how it works with universal discovery. But essentially, in each mainframe, in the mainframe environment, they installed an agent that eView technology provides for the mainframe. They also install on their probes, their universal discovery probes, what is called an eView client. The eView client communicates with that mainframe, and then as you'll see when we go over to the UCMDB interface, you'll see that mainframe discovery adapters exist within the content that's provided by Microfocus, which takes advantage of this eView client installed on the probe and the mainframe agent that's installed on the mainframe. So they got a lot of benefits, with the real-time visibility. But the key thing was with the results they got. They got a very quick return on the investment. They got the operational efficiencies they were looking for by combining everything into a single platform. They were able to eliminate some outdated tools and also eliminate some software licenses that they had, which were specific to the mainframe environment, and then be able to integrate all this into a common technology and provide what we call that single source of truth for both operations and universal discovery. So if I can, hopefully this screen sharing will work. So hopefully everyone can see the screen. It looks like it has come up. Just want to point out a couple things here and then just show you a couple examples of integration between IBM mainframe systems with universal configuration data. So currently, currently I'm in the discovery control panel looking at the different discoveries that are available, and this is something that's part of the discovery content packs that are provided by Micro Focus. So the actual discovery content packs are provided as part of the content packs that you get from Micro Focus. So when you install UCMDB Universal Discovery Probe and load the content pack, then you would see a folder for mainframe discovery. That mainframe discovery then has another folder called eView Agent, because all of these discoveries require that the mainframe have an eView Agent installed and able to do the discovery. And then the discovery jobs are divided up by different components. Currently I've highlighted the LPAR resource discovery, which discovers a lot of the typical host resources, and I'll go through a couple of examples. And then other component areas that are discovered on the mainframe, which is CICS, DB2 database discovery, IMS, IBM's IMS software discovery, and then MQ series messaging discovery. So I'm not going to go through all of these, especially given the fact that we're running a little behind, but I'll just go through a couple examples from LPAR discovery and CICS discovery, just to give you an idea of the integration and how it fits very seamlessly into UCMDB. So if we take a look at one of the mainframe systems here and look at the results of what's discovered from that mainframe system, we'll just go down and look at a couple things. So I'm going to start actually with the physical mainframe. So mainframe systems typically consist of a physical machine, and then they're partitioned very much like a host running a VMware, where you might have multiple operating system instances. A mainframe works very similarly, except the partitioning is done in the hardware. So if we take a look at start with the physical machine, we can see a lot of different attributes that are discovered about the physical machine. And then we can go and look at what's discovered with that and relationships. So part of the discovery is, not only discover the items, but it's going to build relationships between the different types of configuration items that are discovered. So when we look at this particular physical machine, we can see that there are two logical partitions, or two operating system instances that are running on that physical machine. And then we can see a lot of other relationships here, but if we just pick an example here, for example, interfaces, we can see in this particular logical partition, or this operating system instance, we have 3 instances that are defined. We can also see the different IP addresses that are defined or discovered on those different interfaces. We take a look at the other one. Another example here would be, for example, with storage. So if we wanted to look and see what storage groups, which are very similar to file systems and other environments, I'm going to try to make this a little bigger so you can see. Here we can see, for example, on this particular system, a number of different storage groups that are defined. And then if we select one of these, we can then actually see which disk volumes are assigned to that particular storage group. Another example of which this customer had is CICS, where they use a lot of CICS, which are their transaction-driven applications, to be able to look at the transaction information. This information can be used for seeing the configuration, taking the complexity out of the configuration, and then putting it, making it very visible and logical for people that are using this information for mapping, for example, applications to business services, or for using it for change control purposes, where they can track between what's changed in UCMDB and what was planned in the change control system. So if we look at a particular CICS system here, we can see what's called a CICS region, and then see what other types of configuration items are discovered that are related to that. So here, for example, this is just a typical CICS type of configuration where CICS is configured using list, and then within those lists there can be groups, and these lists or groups may represent different services. They may represent application. It just depends on how the application developers have designed their application and configured their CICS systems. But all the information is there that can be used available, and then as we drill down into the groups, we can see the different transactions, and even for each transaction see which program gets executed. So a lot of very useful information that can be integrated and then included in modeling of business services between what's happening, because most mainframe applications typically have front ends that will run on another type of operating system platform, such as Windows or Unix, and then having all this information consolidated into UCMDB, gives them a big benefit in terms of being able to not only see what's changed in the environment and what's in the environment, but also to see service impacts when there are problems detected by the operations manager. So that's really all I'll go through on the demo right now. Hopefully that gives you an idea of the kind of data, the kind of integration that can be done with Mainframe, and how this one particular company was able to do that across a very large enterprise. You can imagine with that big of an environment, trying to do that manually, which is the way it was done previous to integrating with UCMDB. Was a very large endeavor, and prone to not having the right or current data, and having this basically integrated and automated through UCMDB really gives them a much better and much more timely view of what's going on in the environment. So with that, I will turn it over to Brian.
And I would just step in, Chip. Thanks for that quick presentation on the what you were doing there. We have a couple of questions for you, but we'll put that in with the recording when we send it back. You can answer these questions just because of time at this point. So yeah, Brian, let's go to you now.
Okay, thanks, Chip. This is Brian Bowden from Greenlight Group. Let me just forward through some slides here to get to mine.
There you go.
So I want to take a small amount of time today to go over a technical overview of how we took application Syslog data and put it into OBA OpsBridge analytics for dashboarding. So the customer use case, we have a large financial customer. They had IBM data power data in their Syslogs that they needed to get into OBA to do dashboarding for transactions per second and average transaction time. They had a large volume of lines per day within their Syslog. In production, they're running about 35 million lines per day in their Syslog. And the required data for their dashboard was set across multiple lines within one transaction within the Syslog. So there were 17 lines of Syslog data per transaction, and we needed two different lines to build their dashboard the way they requested. So how did we do that? We first we took the data power data and we had it forwarded to our Syslog server, and on that Syslog server we were using the Micro Focus OA agent 12.04 version to do log forwarding to OBA, and we were using the generic output for structured log file policy to do the filtering of that data and to provide that data to OBA. Has to be in a certain format, so that policy does that. And in the 1063 version, OMi 1063 version, that policy actually starts allowing us to use some filtering that wasn't available in previous versions. So due to the amount of Syslog messages that we were receiving for each transaction, we had to find the URL and the transaction latency lines, which there were just the 2 lines out of 17, as I said prior. So once we have all the structured log file policy set into place, and we were able to assign variables for the transaction ID and other pieces of the Syslog data, we were able to then forward that to OBA using the log forward policy. And the actual filtering is done on the log forwarding policy, not the structured log file policy, because there is no way to do suppression within the structured log file policy. So I included a slide here with my syntax for that policy. I'm not sure the level of experience with these log file policies, but just to give a little overview, on the data source tab, you can set up what your standard portion of the log message is. So in this case, it's the date and time and the host name for the log that it came from and the severity. And the rest of we've moved into a variable called rest of the line. And so then we could use that rest of the line within the rules tab to be able to assign variables to the data and then take that data and assign it to field names, which then get passed on to OBA. And so we're forwarding all 35 million lines of data to the log file policy. But on the log file policy, you're able to discard on unmatched or matched or forward data to the next step to OBA. So what we decided to do is we discarded on unmatched, and we decided anything with a transaction ID or the variable transaction that was greater or equal to 1, we would pass it through. And that would mean that that was one of the lines that we actually assign the transaction number variable to. And then we also forward everything that comes out of that. If it has a host name of data power, which we hard-coded in the schema tab, it's highlighted in red on the slide, that will also gets pushed off to OBA. So in the end, we went from 17 lines to 2 lines of data. One line including the URL, one line including the latency of the amount of time for the transaction. So once that data gets put into OBA, it gets put into the ops collection message table. I started to work with AQL and XQL queries to join that data together so we could provide it to the dashboard. Come to find out that there's a limitation within OBA that your data has to be on the same row. So we had to come up with a solution to get around that. So my first solution was to just create a table within the database, create a script to join the data and insert that into the table. Well, we came into another problem that OBA doesn't allow for AQL queries against tables that are not created by OBA. So we had to come up with another solution. So moving forward, we use this OpsBridge custom collection script that's on the application server. Within that script, you can build a table. You have to provide your column names, your data types, and all the different things you want to put into that table. And once that's created, it actually comes through as another integration. Within the source type manager, you can see the name of it when it's created. So that allows OBA to be able to query against that table to build the dashboards. So on some of these, I didn't mention it before, but on some of these slides, I actually include the documentation. There's a link to the documentation on this slide for creating the custom collection table. So once we had the table set up, we had to get the data from the original table to the secondary table. which we just did within an insert script, where we did a join of the two multiple lines in the custom or in the ops collection meshing table. Excuse me. And then there was another table we had to create where we compared some data of source, so they wanted that to be done. So I've included that script here on this slide, and we're running this script every minute. We're using OMi schedule task policy, and I've also included the command that we're using to do the update or the insert into the database. If you notice, there's two different inserts within the script. The first one grabs the data, joins it together, compares it to another table, joins that data together also, and then inserts it. Well, we found that the secondary table that we created, the customer was supplying us with application names according to their IP addresses, and their list wasn't complete. So I built a secondary insert table or insert syntax to insert it in as null if the secondary data is missing, and then we have an update that anytime that it is found to be null, that we update it to unknown. So that allows us to actually dashboard against every transaction, even if we're missing some of the data. So once we get the data in and we can start doing the queries or building the dashboards, then we can customize to whatever the customer wanted. So I'm not able to show the slides because or a picture of that because it was customer related, but I just wanted today to go through the steps that we took from receiving the data in the Syslog to using the OA policy to filter that data forwarded into OBA, and then how we made that data available for the dashboard. So my last slide here is just a couple lessons learned that I learned along the way. Due to the size and the amount of messaging coming through on that Syslog, we ran into a limitation on the OA agent that there's a 2 gigabyte limitation on the log file. So once the log file hits 2 gigabytes, then it stops with the silent fail of forwarding data to OBA. So I got around that by using log rotate, and I included the link to the instructions on how to set that up on this slide. But I rotated every day, plus then I watched for the size of the file every hour. And then the second thing that I learned the hard way, actually, is when you create a custom collection table, you do not assign a column with unique data in it as a key field, because OBA keeps track of those key fields. And what happened in our case was that it started to add an entry into the entity.index table every time a message came through, and so it became very large, and it caused big performance problems with OBA. So just keep that note. It's not a required field. It's the key field that OBA is watching for on each transaction. So that's the end of my presentation. And if you have questions, feel free to send those in. But just a quick overview of how we took data from a large amount of data from Syslog, and we made it dashboardable in OBA.
Thanks, Brian. Great job.
Yep.
Brian from Greenlight Group. So let's go over to Jay.
Okay. Thanks, Brian and Chip. My name's Jay. I'm with Greenlight Group as well. I've been there for close to 9 years, working in the operations space, working with OMi in its many forms, OML, OMW, SiteScope, NNM. So pretty much my whole domain has just been monitoring tools. So that's what I've been doing for the last 9 years. So let's jump right into this. What I'm going to show you is how to build a Vertica query, something a little bit simpler than what Brian was showing you, and then connecting to Vertica with Perl to execute that query, and then posting that data to BVD. Our use case for that is, some of you are familiar with BVD know that you do have a query data source option in BVD, but what we found with this customer is that it wasn't displaying how they wanted it to with the Sparkline widget, and it doesn't refresh if you leave the dashboard up. If you post the data manually every 30 seconds or 60 seconds or whatever it is you want to do, the widgets behave how they wanted. So even though they're constantly updating BVD and making it better, in this specific case, it wasn't acting how the customer wanted. So that was our use case there. Couple of assumptions for what I'm about to show you. We do expect you to have a little bit of scripting knowledge. The scripts that I have in the handout section, those are real, and I do use those, so go ahead and download those. I'll review those at the end. Just go over those real fast. They're not scripts. If you're new to Perl scripting, they're not scripts you'd write on the first day of learning Perl, but they're definitely not overly complicated. Some database knowledge is needed. We're pulling the data from Vertica, but, you could apply this to Oracle, SQL Server, MySQL. It's basically just the same framework all the way around. And then general knowledge of command line utilities. We use curl to post the data to BVD, which is a really nice utility to be using. It's open source and very widely used. So in this use case, what some of the queries that we show you here are for getting operation agent data that's in OBA and Vertica out to BVD. But our use case also was some of the pieces of what Brian was showing you, getting transactions per second, the number of transactions, and the average transaction time committed over a minute or 10 minutes or an hour. So really any metric data that you have in any database, you can throw up BVD. It's all JSON. Here's the Vertica help link. A really nice web page to navigate. It has a lot of good information there. When you're building your query to post your data to BVD, it's nice to visualize that. We've used DB Visualizer. It is a free download. They do have a pay-for version, but for what I was using it for, the free version worked quite well. It also has a built-in Vertica driver, so that's nice to have too. So here's a sample query that we have that was doing the disk byte rate against a server called slcvp nni.greenlightgroup.com. So it's my NNMI server in my dev environment. We're pulling that out and then posting that to BVD. Now, when you use the query, one thing that I got caught on was when you put that in the context of a script or something outside of your database query tool, you do need to put the ops_default database because it can't find it. It doesn't really throw an error that's really readable. It says something about just table doesn't exist, so you have to point it to the right database. Now, time selection, what we did find as well when we were doing some of the data power transactions was that it does take about 90 seconds for OBA to process the data and get it into the right table. So what this where clause does with the timestamp is we found that if we chose data that was older than 2 minutes and newer than 3 minutes, so just in that 60 seconds, we would not get a null data set. So we could always make sure that we're posting the right data to BVD. If you're just posting, you just want the latest, CPU metric, then you could just take the last line in your or the first line in your query. But when you're trying to calculate metrics over time, you need to make sure that all of the data that you're looking at is actually there. So that was another kind of gotcha that we ran into. So that where clause should help you with that when you're doing that type of thing. So once you have your query built, you're getting the data that you want, we need to plug it into the Perl script. Of course, you can use whatever scripting language you're familiar with, but here's a good example of that. So how Perl works is it uses the OS ODBC driver and data source names to connect to your database. So I tried to use Linux. I'm not a Linux admin, so I had a hard time setting up the ODBC driver and data source name on a Linux box. So just for sake of time, we moved to Windows, and that was set up pretty easily. My background is Windows admin as well. So there's a link to download the client drivers. Again, my.vertica.com is a great website to navigate. It's really easy. So we'll take a closer look at this short script here. So again, not overly complicated. What this script will do is go ahead and connect to your Vertica database. So where we have Vertica DSN, that's where you would plug in what you called your data source name on your Windows or Linux box. And then the use DVI module just grabs that. If you plug in your user ID and password, I think for Vertica it's dbadmin is the default. And then we have a fail message if we can't connect. Then we come down to where we say my query here, so that's where you put your Vertica query. And then the while loop, after you execute that, the while loop runs through that and puts it into an array, and then the print dumper command prints out your two-dimensional array to verify that if you got the data from the database and it is now in your array. So again, not overly complicated. You can copy and paste this in, have in the handouts, and just run this to see if you've got everything configured right and are connecting to your Vertica database. So then we need to post the data to BVD. So there's two versions of BVD out there right now. There's a containerized version and your classic version, which is just the standalone server type. The URLs are a little bit different. The link I have there is for the full integration guide, but really it's the two pieces of information that you need to concentrate on. Your API key in BVD, you need to make sure that you log in as the admin, not a user who has admin privileges, but the actual admin, so that you can view the API key. On the right-hand side here, we just see we click on the wrench, we go to API key, and then there's your key, and you plug that into your URL. So one thing we want to look at here, I have some highlighting on here that's kind of gone, so I'll talk through this. At the top here, we see our URL. So this is for a classic installation. By default, it uses port 12224 to post the data. The 5s represent where my API key would be. Now, up to the dims / that's always going to be the same for anything you post to your BVD server. Everything to the right of dim / is going to be where you customize your data stream. So we have host, metric name, and Uncle Joe. So going down the left-hand side, we see dims are required in your JSON payload. So we see host equals our IP address, metric name equals server stats, and Uncle Joe equals live and kicking. So on the right-hand side, we see our data channel of our IP address, server stats, and alive and kicking. So really, I threw Uncle Joe in there really to show you that it really is arbitrary to what you put in there. So whatever data stream it is you're putting in there, you can put whatever you need to make it unique and easy to find in BVD when you start attaching the data streams to your widgets. And just a word on the JSON file over here on the left. If you've worked with JSON, you know that that's not actually formatted correctly. We have the backslashes because we're talking in the context of a Perl script. So we have to escape the double quotes with the backslash. If you were to just create this file, and if you were to copy and paste what I have here and put it in a file, you would need to remove the backslashes, and then where we have the variables $, CPU utilization, $, physical memory used, you could just hard code a value there, just so you can understand how it works, and that's how you would format JSON. So again, but we're talking in the context of a Perl script. Now, how do we post the data? We use curl. This is an extremely widely used utility for Windows and Linux. Also, Android phones use it for their web browsers, so it's really, really distributed very widely. You can download that at curl.hacks.se. So this is the curl command that we use. Again, the double backslashes are in context of the Perl script, but if you were to just do this on your own, just to try this command and post some data to BVD, you can just run this on the command line. You know, of course, substitute your BVD server name, your API key, and then where we have the $data file to hard code that with where your JSON file is. So what I'm going to do now is just review the two handouts really quickly. Let's see, share my screen here. Okay. So the first script, this is actually a real script that we're using in customer environment. You'll see here this starts out with the thing that we've already talked about, getting your data and then printing it out to make sure that you actually see your data. The thing where you'll need to have some scripting knowledge is I don't know what data you're going to pull. This just gives you an example of how to pull some data out of your two-dimensional array and putting it into a variable. Then we open our file handle, we write our data to our file. So right here we see our data file, and we declared that at the top. Right here, this is where my data file is. So we write our data, we open the file handle, and we write our data to it, and then we close our file handle. And then we post it to BVD using Perl. We capture the result in a variable, and then we print that out so we can see what that would be. So if you get an HCP error, you get a 400 denied or something like that, you'll be able to see that. So again, not overly complicated, not going to be your first Perl script you ever write, but if you have any scripting experience, you'll see that there's not a ton here. The second script I have here is completely self-contained. This doesn't connect any data source. Basically, we just generate some random data and throw this to your BVD server. So if you're new to this whole thing and you want to see how it works, you can use this script as is. The only thing you really need to do is plug in your BVD host name and API key. Looks like I lose the screen share. Yeah. It looks like, did I lose the screen share here? All right, let's stay there. Okay. You just need to plug in your host name and the API key, and this scope will run. You just, any pathing that you need to adjust is fine. So I put this whole thing in a while loop, so it'll run a million times, and then at the end of it, you see I post a bunch of data here. We sleep for 60 seconds, and we increment, and then we do it all again. So we'll run for a million minutes. If you want to make that less, that's fine. You can just change this number here. So that's what I really wanted to show you, was just quick ways to get data into BVD from whatever data source you have. So obviously you could substitute a SQL Server data source in your script. You could substitute Oracle, to post your data over there. And these scripts right here, like I said, are examples that I'm using right now in customer environments, so they should work for you. That's all I have.
Great. Perfect timing. Thanks, Jay. So if you
no problem.
I want to thank everyone for bearing with us through all the technical difficulties, and we had a number of them. And as we work out the bugs of this new platform, thanks to the presenters for sharing their customer use case scenarios, which is what SIG Talks is all about. If you've got any questions, feel free to post them, and we'll get to them. We've seen a lot of the technical issues questions, and I think we're trying to resolve that. But if you've got questions for any of the presenters, feel free to add them here. And Chip, are you still on the line? Just wanted to check.
I am.
Chip, I think I've got a couple questions for you. One for sure, how is the eView, where did it go here? And you may have already answered it. It was, how is eView licensed?
Yeah, I did. I just typed an answer in there. The license is based on a physical mainframe system, regardless of how many logical partitions or the capacity of the system. It's just a single license per mainframe physical box.
Great. And then you have that other question, does eView work with COD or capacity on demand? I guess I don't see the whole thing, but.
And the answer is Yes.
Okay. That was tough. Let's see. Any other questions? We've got like 1 minute. Well, if you do, please feel free to send them to our Twitter site. But just to let you know, we've got an upcoming Vivit webinar in the IT operations space, single pane of glass solution from, I don't see it on here. I think it's Edge Technology or Edge. So that's coming up in July. And with that, please take the survey. If you can, let us know what you'd like to hear from other customers or partners or their experience with implementations. That's what this whole SIG talk is about, sharing customer customer and user experience type scripts and customizations and basically trying to make the products work so that you can fit your environment. So I think with that, we're done. Again, I want to thank everyone for hanging in there, as well as our speakers for job well done, and we'll see you next month. Thank you, everyone.
Great, thanks.